Hey, good people, Arthur Morris here. I hope all is well. In this video, we're going to look at the chain rule. So if you look on the left here, well, in this video, we'll find the derivative of a composite function using the chain rule, the general power rule. We'll simplify derivatives, and we'll find the derivative of trigonometric functions using the chain rule. So on the right-hand side, so we can tell the difference of when we use the chain rule and when we don't use the chain rule. We've seen the single functions y equals x squared plus 1, sine of x, 3x plus 2, and x plus tangent of x. But if we add an extra layer to that, for example, y equals the square root of x squared plus 1, then we use the chain rule or the general power rule, but we'll call it the chain rule. So we would rewrite that in exponential form, and then we would use the chain rule, which we'll go over in just a minute. Sine of x is different from sine of 6 of x when we add that extra layer, that number in there. Y equals 3x plus 2 versus y equals 3x plus 2 to the 5th power, where we have that exponent outside of the parentheses. Again, we'll use the chain rule there. And x plus tangent of x squared with that x squared, again, we'll use the chain rule there. So the chain rule basically says that to find the derivative, if y equals f of u is the differentiable function of u, and u equals g of x is the differentiable function of x, then f of g of x is differentiable. It's a differentiable function of x. And dy dx equals dy of du times du of dx. So to find that derivative of that function, it's good to look at that general power rule. It kind of helps. But you find the derivative of the outside function times the derivative of the inside function. Okay, so if you want to pause the video and write those two theorems down, we'll go over exactly how to use these theorems here. And we normally just call it the chain rule. But within the chain rule, a lot of times we use the general power rule, where if we have an exponent outside of the function, we would use the power rule first, so bring that exponent down in front, and then we would find the derivative of that u of x of the inside. Okay, so let's look at a couple of examples here. So we have y equals 5 times 2 minus x to the third raised to the 4th power. So the power rule, we'll start off by bringing this 4, the exponent of 4, outside, multiplying it times 5. But since I can also find the derivative of the inside function here, let's go ahead and say 2 minus x to the third. So we start off by using the power rule, but then we have to find the derivative of the inside of that function. So 2 minus x to the third, derivative of 2 is 0, derivative of negative x to the third is negative 3x squared. And then from there we simplify. So 4 times 5 is 20, times 3 is 60, negative 60, x squared. Okay. So number 10 is similar to number 9. Again, we have 9t plus 2, and we've done derivatives like that, but now we have that extra layer with the exponent outside of that, so we use the chain rule. So the power rule first. So we're subtracting 3/3. That gives us negative 1/3. Times the derivative of 9t plus 2, which is just 9. Then let's clean it up just a little bit. And I think the computer does allow negative exponents. I normally make my negative exponents positive when possible. So 2/3 of 9, 3 goes into 9 3 times 2 is 6 over 9 t plus 2 to the positive 1/3. Alrighty, number 12 here. We have g of x equals the square root of 4 minus 3x squared. So again, you want to rewrite that in exponential form. And then once you write it in exponential form, you want to use your chain rule. So the power rule first. So subtract 1, which is the same thing as subtracting 2 over 2. And then multiply that times the derivative of 4 minus 3x squared. So derivative of negative 3x squared, negative 6x. Simplify it. So 1/2 of negative 6x Alrighty, number 17 here. Now, problems like number 17, you could use the quotient rule if you chose to. So you could do the low D high minus high D low over low low. But since we're working with the chain rule and the general power, I'm going to rewrite that x minus 2 that's understood to be to the first power. I'm going to bring it up to my numerator and change the sign of the exponent. So bring the negative 1 out in front, subtract 1, multiply times the derivative of the inside. Derivative of x minus 2, derivative of negative 2 is 0. Derivative of x to the first power is simply 1. And then I'm going to bring that x minus 2 down to my denominator to change the sign of the exponent. Okay. All right, number 18 here we have s of t equals 1 over 4 minus 5t minus t squared. Again, this one we don't have any parentheses with an exponent on the outside originally, so you could use the quotient rule if you chose to. But again, since we're working in this lesson, I'm going to go ahead and bring it up and use the chain rule. So remember, this is understood to be to the first power. So when I move it up to my numerator, that will change the sign of the exponent. Okay, so after I move it up, now we need to go ahead and let's use the quotient rule. So start off by using your power rule. So this negative 1 exponent comes out front. Subtract 1, so that makes negative 2. And then the times the derivative of the inside. So derivative of negative 5t is negative 5. The derivative of negative t squared is negative 2t. So s prime of t equals, I'm going to clean this up a little bit. So I have this negative that I'm going to distribute to this second parentheses here. So that makes that positive 5 plus 2t, or 2t plus 5. And then I'm going to move this down to my denominator to change the sign of the exponent. All right, so you end up with 2t plus 5 all over 4 minus 5t minus t squared to the second power. Alrighty, let's look at number 21 here. So again, I want to rewrite this in exponential form. And then I want to move that up to my numerator. And then I want to use my power rule. Subtracting 2 over 2 would make that subtracting 3 halves, negative 3 halves, times the derivative of the inside, which is 3. And last but not least, let's clean it up. So we have this negative 1/2 and 3, so I'm going to make that negative 3, and then the 2 would be in my denominator, times the 3x plus 5 to the positive 3 halves, because I moved it down to my denominator to change the sign of the exponent. Alrighty. Trigonometric functions and the chain rule. So we have some trigonometric functions. So it says the derivative of sine of u with respect of x is cosine of u times u prime. Derivative of cosine of u is negative sine of u times u prime. Derivative of tangent of u is secant square u times u prime. The derivative of cotangent of u is negative cosecant square u times u prime. Derivative of secant u is secant u tangent u times u prime, and so forth. Okay. All right, so let's look at this one. We have y equals the cosine of 4 times x. So if it was just cosine of x, then it would just be negative sine of x, of course. However, since we have that 4 there, and you're still using the same rule, even if it was just cosine of 1x, then we know the derivative of 1x is simply 1. So the rule stays the same. We just did not have to use, per se, the chain rule. So if u in this case is equal to 4 times x, then u prime, the derivative of u is equal to 4. All right, so negative sine of 4x times the derivative of 4x, which is 4. So clean it up a little bit, bring that 4 out front. So negative 4 times sine of 4x. Alrighty, number 47 here, we will have y equals sine of pi x squared. So in this case, the u is pi x squared. So let's write that as, and remember pi is just a number. So let's write that as pi squared times x squared. Therefore, u prime is just going to be 2 times pi squared x. All right, now we have y prime, derivative of sine is cosine. So we have cosine of pi x squared times 2 pi squared x. So y prime equals 2 pi square x times the cosine of pi x squared. So not too terribly difficult. Just your regular derivatives that we've been looking at times the derivative of that u of whatever cosine is or sine of whatever. So okay. Find the second derivative. Well, remember to find the second derivative, which represents acceleration at any given point. we find the first derivative and then find the derivative of the first derivative. And that gives us the second derivative. So number 87 here, let's move this x minus 6 to our numerator. And then let's find the derivative. So power rule times the derivative of x minus 6, 1x minus 6, which is just 1. All right, so that's the first derivative. However, which represents the speed or the rate of change at any given point. The second derivative we want to find is just the derivative of the first derivative. So we just move on to the next step here and we go through the process again. So we have this negative 2 here. So now I have negative 2 times the negative 1 that was already out there, times x minus 6, subtract 1 from the exponent, times the derivative of the inside again, which is 1. All right, clean it up. So negative times negative makes positive 2 in the numerator. Move that x minus 6 to our denominator to change the sign of the exponent. Let's put a second tick there to represent the second derivative. Alrighty, number 89 here, we have f of x equals sine of x squared. So the first thing we recognize is that we're going to have to use the power rule or the chain rule because we have that x squared. So f prime of x, derivative of sine is cosine, so we have cosine of x squared times the derivative of x squared, which is 2x. Okay. So f prime of x equals 2x times cosine x squared. Now we're multiplying two functions. So now remember, if we're multiplying two functions, then we have to use the product rule, which says the first times the derivative of the second function plus the second function times the derivative of the first function. So for my second derivative, I have to use the product rule. So the first function, 2x, times the derivative of the second function. So in the second function, that cosine of x squared, we have to use the chain rule to find the derivative of that. So we have cosine of x squared. Let's see here, get a set of parentheses in here. So cosine of x squared times the derivative of x squared, which is 2x. And sorry about that. Derivative of cosine, that will make that negative sine of x squared times the derivative of 2x. Okay. Now that's the first part of the product rule. First times the derivative of the second plus the second cosine of x squared times the derivative of the first function. So the derivative of 2x is simply 2. I'm running out of room there. Sorry about that. So you have cosine of x squared times 2. Now we need to clean all of this up. All right, so f double prime of x. I have 2x in this first part here. I have 2x times negative 1 times 2x. So 2x times 2x is 4x squared. Keep the negative, so negative 4x squared times sine of x squared. And then here I'm just going to bring this 2 times the cosine of x squared. All right, so again, since the first derivative was fairly straightforward, cosine of x squared times 2x. However, we ended up with 2x times cosine of x squared, where we were multiplying two functions and had to use the product rule. So remember, the product rule says the first function times the derivative of the second function plus the second function times the derivative of the first function. Alrighty, good people. I hope you found this video to be helpful, and I will see you on the next one. Thank you.